Hi everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. We are into unit number 2 where we are learning about regular expression. In the previous lecture, we have seen the state elimination method for conversion of a finite automata to a regular expression. And we have seen two basic examples. Now I'll be looking into these three examples and we will try to solve it. Okay. And the concept behind the solving of this is that you have to follow the three steps that I have told you in state elimination method. So as fast as we can do, then we will start off with the session right now. Okay, so look at the example number 3. In example number 3, actually it is a very simple one, but just for the sake of understanding if these kind of scenarios also happen, how to write down, how to eliminate. Okay, see, we are having three final states. We are having, as you can check it out, there is three final states. Okay, now we have to eliminate like state B, and if you can look into this scenario, B, from B it is going to C, D, E, and these are all in the same direction. It is going in 1, it is going for 0, it is going for 1, correct? So all are in the same direction. So besides taking the three different final states, I can take one single final state. So like this, 0. From B, I can take a single final state to, suppose I am taking as F as the final state, suppose, okay? So that means this particular transition will be what? I have already told you A plus B. That means this will be of union operator, that is 1 plus 0 plus 1. Correct? All are in the same direction from one same state only to another state. Okay. Now you might be thinking that yes, B, from B it is going to C, it is going to D, it is going to E. But these are, suppose if it had been in a different state, normal state, then we cannot add all these things, because all these scenarios, because these three states, if you look into, these are all final states. So why to use three states besides taking only a single state? So in this scenario, you can add this, you can make a union. But if these three would have been different states, normal states or a final state or a normal state, then you cannot add these three things because it's going to a different states. But as it is a final state, so I have combined together into a one single state. That's why I've taken this example. Okay, so finally I got this. Now I just want what do I need to do? I need to eliminate this state B. So initial step is always clear that we have to check from initial state there should not be any kind of incoming edges. There is no. Second step is says that from final state there should not be any outgoing edges. There is no outgoing edges. So that's why I have directly jump over to this. This is actually step number 3. Now if I eliminate state B, what will be the answer? The answer will be like this. From A, there will be a transition to F, correct? And the formula will be what? 0 dot expression will be 0 dot 1 plus 0 plus 1. Therefore, the regular expression will be what? The regular expression will be 0, 1 plus 0 plus 1 will be the final answer for this. Okay, the final answer will be this one. As clear as that. Okay, now move on to next question. Question number 4 we'll be doing first, then we'll be moving to question number 5. Okay, now let us check what question number 4 is all about. Question number 4 is not that much tough, but it is a little bit tricky, and you have to check one particular step for this. Okay. Okay, so I'll move a little bit fast, and I will try to check it out that can I make the first step and second step together. Okay. Look into the first step. First step says that the initial state should not have any incoming edges. Correct? So step 1 says initial state is having an incoming edge. So I have to make this as a normal state. So how to do that? I have to take one more state as S as the initial state. From there, I have to take a epsilon transition to state A. And from A, the concept, the diagram will be similar of what it was already having. From A, there was a transition for B. From B to A, there is a transition for A. Okay. From B, there is a self loop for C. From B to C, which is the final state, we are having a transition known as D. Clear? So step 1 is perfectly done. I have created a new state, initial state. Now in step number 2, there is no outgoing edge from final state. I think it's clear to everyone. Correct? There is no outgoing edge from the final state. Correct? So let us move to step number 3. Now step number 3, what it says, if initial state doesn't have any incoming edges and final state doesn't have any outgoing edge, then we can eliminate other states one after another. So let us move. So what we can move, now what we can eliminate? We will first try to eliminate state A. Why? Because this kind of scenario already you have seen in previous example. Correct? So if I eliminate this state A, what will be the answer? Let us check. S will be the initial state. Then from this we'll be having a transition that will go to B. Correct? And this will be nothing but epsilon dot B. Clear? Then C was at state B, there was already a self loop for C. That means one more self loop will be there from B, as you have already studied this kind of example in the previous class. That from B you can check one transition going to A, and from A there is a transition to B. Logically we can think of this as a self loop following over B. Correct? So what will be the self loop transition? It will be A dot B. Correct? So I can take one more self loop, and this self loop will be A dot B. Whichever direction it is going, you have to write first that one only. If it is B, then A, then it will be B dot A dot B. But finally, if you apply commutative property, then A dot B is equals to B dot A only. Correct? So I have done with the elimination of state B, A. Now here one more state transition is there to state C. So what I did, I have eliminate state A. Correct? In this scenario. Now step number 4, I think it is almost clear. Now you can do on your own. So now, one important thing that I have to explain to you in this scenario. See, look into this particular state B. There are two transitions, okay? But the two transitions is going out from B and coming inside to B, making a self loop, correct? It is having a C as a self loop. That means it is coming out of B and it is coming inside B only. And one transition is C and the other transition is A dot B. So that means we can make these two transitions as similar one. And which operator you have to use? You have to use the operator union, correct? So that means if I write down as the initial step, then epsilon dot B will be B, correct? In state B, I have to take one self loop only, merging these two as together. So C plus A dot B, correct? And then finally I am having one more transition D that is moving to final state C. Clear? So I am left out with state B. Again we are going into the same direction. B dot this part whole to the power asterisk dot D. This is the final answer. So I can write it down. So what I have eliminate, I have to eliminate state B. So if I eliminate state B, then the transition will be like this. S will be the one, and from S there will be a transition going to the final state, that is your C. And this transition will be nothing but B dot C plus AB whole to the power star dot D. Correct? That means the final answer, therefore the final regular expression will be what? It will be B C plus AB whole to the power star D. So this is the final answer for this particular diagram. I hope every steps are clear to you all, and this is a new thing that you have understood. Okay, you have to actually work with few of the examples, then it will be clear how the transitions are actually going. And you have to understand the basic 3 parts that I have already taught you, the basic 3 symbols of conversion of a regular expression to a finite automata, where I have shown you the A plus B, how to draw, A dot B, how to draw, and A to the power star, how to draw. So if you haven't understand, or if you haven't gone through those lecture, then I would suggest please look into the lecture where we have studied about conversion of a regular expression to a finite automata. Okay, there I have explained you the symbols. Now this is a vice versa process that you are studying. Okay, now moving into the last topic, last example number 5. Okay, so what does this example number 5 says? You can pause the video and you can try on your own once. Okay, so let us check it out, what this example number 5 is all about. Okay, the example number 5, first we have to check that whether there is an incoming edge to the initial state, that you have to check, and then you have to check whether there is a outgoing edge from a final state. As this particular diagram is having initial and final as same, and we are having both incoming edge and outgoing edge, definitely step 1 and step 2 need to be followed, correct? So what I can do, I can directly write down the step. Okay, I think it's visible to everyone. Okay, fine. So I can write down as a new state I can take as suppose QS. From QS I can take an epsilon transition to state A. Okay, as it was a final state, you can show in you have to show in different steps, but I am showing in one single step as well. Okay, I'll make A as a simple step, and from A I have to make a epsilon transition, and I have to make one more state as a final state. So I am taking as QF as the final state. Okay, and then in state A other structures will be same 0, and then I am having a transition 1 to state B, correct? And then in B I am having a transition 0, and from B to A we are having a transition 1. Now I can eliminate one after another. How to eliminate? Basic operation, if I eliminate this, then it will be easy for me. Okay, so this is step number 1 and 2 both. Okay, you have to show it separately, but I have shown in one step only. Okay, now step number 3 we will be looking into. Now step number 3, what it says, I have to eliminate the state B. How to do it? So let me draw the first QS epsilon transition moving to state A. State A was already having a self loop of 0, and from A there is an epsilon transition moving to the final state, that is your QF. Okay, now if we look, if we eliminate this, you don't think that this is a transition like diagram similar to this scenario? Correct? If you look into this, 1 will be nothing but B, 0 will be nothing but this one, correct? And 1 will be nothing but this D, correct? So that means if I eliminate this, then there will be a self loop. This is a self loop, right? If you imagine, if you logically see this scenario, this is acting as a self loop. So definitely it will act as a self loop. And what will be the transition? 1.0 star dot 1. As simple as that, correct? Now I have already taught you how to do this. Okay, if in the same state, say two self loops are there which are having different transitions, then you can merge these two by using the union operator. That means in step number 4, what I can do, I can merge these two scenarios. That will be QS moving a epsilon transition to state A, and from state A there is a epsilon transition to the final state, that is QF. And in state A I can merge these two self loops. And what will be the answer? Can anybody let me know? How can you let me know, right? We are not taking any live classes, so you can comment down below as well, and you can pause the video and can think of it. Okay. So actually I usually have a habit of like asking this because sometimes I used to take live classes. So this is like a habit. Okay. So if I merge these two self loops into one, what will be the answer? The answer will be 0 plus 1 0 star 1. Correct? You already know about in previous example we have discussed about it. Now if I'm left out with only state A, I think it is now clear to everyone. So I will show you it upstairs. Okay. In step number 5, what we have to do? Step number 5, I have to just write down the initial state as QS. From initial state there will be a transition to final state. Final state is what? QF. Okay, what will be the transition? Epsilon dot 0 plus 1 0 star 1 whole to the power star dot epsilon. Correct? This is a self loop, right? You have to take the as a whole and you have to put as a asterisk. Therefore the final regular expression will be what? The final regular expression will be 0 plus 1 0 star 1. This is already a self loop, correct? And whole to the power star. So this is the final answer that I have got after converging this particular automata. Okay, so this is I think clear to everyone, where we have learned about 3 more examples of different scenarios where we have converted the finite automata into a regular expression. Okay, these 2 examples are enough to understand the concept. Okay, now in the next lecture we will look into a new methodology which is known as Arden's theorem, and we will also learn how using Arden's theorem we can convert a particular finite automata into a regular expression. Okay, I think everyone is clear, and if anyone has not seen my previous video lectures, I would suggest please go back and watch those videos, because all the videos that I'm uploading is in a sequential order. Okay, so thank you for watching the video, and also comment down below if you're having any kind of suggestion, and also click on the bell icon that you can see, and do subscribe my channel. Thank you for watching.